Maiken and Kai from Aarhus University and Floyd from the Exertion Games Lab, who's also giving a presentation later in this session. So this paper is about an interactive sports training platform, a study, and 3 challenges that came out of our experiences building this system and conducting the study. So here's a quick picture of what the bouncer looks like, as we like to call the platform. But this is just to capture your attention, and then I'll return to it later. So first, the motivation behind making an interactive training game is that training can be boring, and it can be hard to find the motivation in doing individual workouts. So recently there's been plenty of examples where technology has been used to leverage sports training, as it offers variability and support in these different exercises, and also a quantification of player progress. Moreover, technology allows us to add digital game elements and mechanics to the training, and can be used as a way to motivate and engage these players and athletes. However, these game elements also impact the training and the way it's performed, and they also introduce a risk of reducing the training relevancy or the transferability of the training, if you will. So with this work, our goal is to investigate how to balance these engaging game elements with the relevant training for an actual sport, and thereby add the limited knowledge on how to actually design these training games. So this paper and our training game takes outset in team handball, and just because I know that many of you are familiar with it, I took this little video with it. So team handball is played by 2 opposing teams, each trying to score by throwing the ball past the defense and into the goal behind the goalkeeper. So in our work, we focus on one aspect of this game, namely the jump shot, where a player gets the ball, jumps up into the air, perceives the situation and the goal, makes a decision, and then throws the ball into the goal. And as you can see here, all this happens in a very short time. So here, he's doing all these things, perceiving, making a decision, and throwing, and then ultimately he scores in this clip. So currently, the jump shot is trained like you see it in this video, where a player runs towards the goal and just finishes. However, the cognitive load in the decision-making process is very limited in this example compared to the one we just saw in handball. So furthermore, the player's training is also very dependent of the goalkeeper and his skill set, his ability to predict how the player is acting and also make decisions. And in the end, the player is also actually reliable or dependent of just having a goalkeeper present, because if he's not there, then he has to put cones in the bottom of the goal or hang jerseys in the corners, and thereby use like predetermined and static targets instead. So as a response to this, we developed the Bouncer, and this is an interactive training platform. And the Bouncer is basically a 3x3 meter frame strung with wire that is called an M-station. And we equip this with sensors that enable us to detect ball impact with an accuracy of around 10 centimeters. So further, our projector shows a screen that enables an interactive interface that you can control with the ball. However, there are some strong issues with the Bouncer and its relation and relevance to handball training. For instance, as you can see, the movements of this very handsome player, it's me, is very static and such very unrelated to handball and the videos that I showed before, both the training and the actual example. So to kind of overcome this and improve the relevance of the system, we invited 3 sports scientists with expertise in handball to participate in a design workshop evolving around the Bouncer. And from this design workshop, there emerged 2 main findings. So first, the Bouncer should go beyond just hitting a target and training only precision and reaction. We should somehow utilize the system to train cognitive skills and decision making. And this is when we decided to focus on this in-air decision-making part of the jump shot. Secondly, we need to add, we found that we needed to add another sensor to the system as a way to overcome this static interaction and encourage the players to move more relevant and handball-like. So in response, we created a touch plate sensor in the floor in order to detect whenever a player jumps. And this made us end up with a new game concept where the player has about 40 seconds to score as many goals as possible. And they pick up a ball about where the camera is standing and then runs towards the Bouncer, jumps off the touch plate, which then reveals the possible targets on the screen. Then they have to make a decision about what they see and then shoot the ball in air. And the movements of the player now resemble those from handball much more than we saw in the previous examples. And this allows them to train without a goalkeeper being present. And it also forces the player to make some in-air decisions as the target does not appear before the jump. So in order to investigate how these choices and designs of graphics affected the players, we created 3 different variations of the game, which I'll now explain in detail. So every game starts with a 3-second countdown, like this. And then you go to this intermission screen showing time and score. And then the player runs towards the jumper, the bouncer, and then jumps up in the air. And in the first game he sees this. And this game is called Yellow-Black. It's pretty straightforward, so the player has to hit one of these 3 targets where he gets awarded an amount of points based on the size of the target. So the smallest target gives the most points and vice versa. So this forces the player to choose between getting few points and hitting a sure target, or getting several points from hitting a difficult target, or missing, for instance. So perceiving the targets and making this decision and shooting the ball all has to be done in air. And then when he either hits or misses, he goes back to the intermission screen that again shows how much time is left in the exercise and what is the current score. So the second game variation is a little more complex, or at least the graphics are, and called counter stripes. Again, the player runs towards the bouncer, jumps up in the air, and then sees this. And the concept is pretty much the same as in the other, but the targets are, as you hopefully can see, a lot harder to perceive. So the thought behind this was that the open places to shoot in a goal might not be as obvious as we saw it in Yellow-Black or the other game. And if the player uses longer time to perceive the goal and find the opportunities for scoring, there might be less time to make a decision and shoot the ball. And we tried to simulate this harder perception in this game variation. So the last game variation is called color match. And again, the player runs towards the bouncer, jumps up in the air, and sees this. And this variation is very different from the other 2, as the player has to identify the target that's in the middle of the screen, and then locate a matching target at the edge of the screen. So the idea behind this is that the player kind of reads the goalkeeper and sees how he is standing in the goal, and then makes a decision based on that. And in this game, all the targets get the same amount of points, so here he doesn't have to make a decision based on that. So for all the games, we created an extra level just to make it more exciting, and Yellow-Black and Counter Stripes has the extra level is done by making the first or the biggest target disappear within the first second. And this is to kind of simulate how in handball a known goalkeeper technique is to open the goal in one place, to lure the player to shoot there, and then close it off again. So this was the idea behind this level. And in color match, we just increased the number of colors that we used. So instead of having 4 colors twice, we only had 8, or we had 8 colors once only. So that was way harder than the first one. So to evaluate the bouncer in the games, we conducted a study with 10 experienced handball players, and they all played the game 3 times, or 2 times on both levels. And each game was followed by an interview, and then we ended it all with a retrospective interview about the whole system and all that stuff. So all the games were recorded on video from 3 different angles, giving us some really nice material to look at afterwards. And the study resulted in 10 really nice findings describing the players' experiences with the system. Because of the limited time in this session, or for this talk, I encourage you to read the paper for an elaboration on these really, really interesting findings. Okay, so instead I will now present what we pulled out of the findings. So here I present 3 challenges that emerged in the design of interactive sports training games, as well as 3 strategies for approaching them, the challenges. So the challenges and strategies are based on both the design workshop, existing work in the field, our experiences from the design and the development of this system, and 4th, a synthesis of the findings from the study. So the first challenge is how do we maintain relevance when translating physical elements into a digital representation. So in most interactive games there has been some sort of translation from a physical to a digital space. And this could, for instance, be an opponent or a target displayed on the screen, as in our example. Or it could be light or sound signals, for instance, illustrating some co-players. So as the designer, you have a choice between a literal translation, such as a virtual simulation of a goalkeeper, or an abstract translation, as in our games. And choosing a literal translation poses a range of technical requirements, as the players potentially have the same expectations to such a literal representation as they would have to its physical counterpart. And so a goalkeeper simulation would require really complex and expensive sensing and interpretation of players' movements in order to enable intelligent reaction to the simulation. So maintaining relevance is therefore not a matter of keeping the digital space as close to the physical as possible by just replicating the elements. Instead, it's about extracting relevant aspects of the game and translate them in an appropriate manner. So our study indicates that although abstract graphics in our game look nothing like the goalkeeper, the players found them relevant to handball anyway. And furthermore, abstract representations provide a possibility to train cognition and decision making, and our study showed that the players found the game to give them an extra dimension that they didn't get from their regular training. And this forced them to think in these in-air shooting situations, which they really showed to enjoy. So the second challenge is choosing the appropriate level of sensing as game input. And in our initial work with the bouncer, we realized that only sensing the ball impact was not enough, and we needed to add an extra sensor to encourage these handball-relevant movements. Contrary, games that are based on sensing and dictating every movement of the player will affect them in a negative way and reduce the sense of meaningful play. So, for example, by sensing shot power in order to only award powerful shots could potentially increase the relevance of our games, but it would also retain the players from choosing finesse shots and trying out different strategies in that regard, thereby minimizing the real fun and also maybe the benefits of the system or the game. So therefore we suggest to allow for autonomy in these games and leave most decisions to the player, hopefully with the result of an increased engagement. And in our study we saw that players really enjoyed trying out different jumping and shooting techniques in order to get the highest score, which make them reflect on their regular movements in their regular technique that they used in real handball. So instead of increasing the level of sensing as the game input, our study suggests that changes to the physical space, such as introducing various physical obstacles, could have a better impact on the relevance. However, it's important to note that sensors could of course be used to gather a lot of player data on the player performance, and our challenge is based merely on using this sensing as an input for the game. So the last and third challenge is to introduce points in these exercises without reducing relevance. So points are really good in many ways, as they can motivate players, and they can create a competition, and they can also give players a way to measure their performances. However, in our study we saw that at least 2 participants whose desire to get a really high score caused their movements to deviate from their usual handball practice. So this issue has also been covered in some previous work, as I mentioned in the beginning of my talk. So we suggest that when using these game elements, and points especially, it's very important to frame the game as training. This keeps the player in some sort of training mindset, and where they are aware of the sport and the purpose of what they're actually doing. And by doing this, the 2 players whose movements deviated in our study actually ended up reflecting on why they did this and related it to their regular handball movements. So further, we suggest that optimal movements are generously rewarded by the game, and if the game can be cheated in some way, framing the game as training will not be enough for a long-term solution. So therefore, a designer should strive to reward the optimal movements of behaviors in a system. And this sounds really obvious, but however, it's really not as easy as it sounds. So all we encourage is that you think about, can this game be cheated? And oftentimes you can first look back at it some months after it's been played and then see where the pitfalls are. So in conclusion, we believe that it is possible to make engaging and relevant games for sports training, but we strongly recommend to synthesize for these different challenges in order to make the games as fun and beneficial as possible. So in conclusion, or to sum up, I've presented the Bouncer, this interactive handball training platform, a game concept with 3 game variations, and then I proposed 3 challenges that emerge when designing these games, as well as 3 strategies for approaching it. Thank you very much.